Okay, last time we discussed how distance time graph and different curves, what do they mean, and how can we describe the motion if it is not a straight line graph. And now we will be doing some velocity time graph and finding some quantities numerically from a speed time graph. More about speed time graph. One more fact is area under speed time graph is numerically equal to distance traveled. So this is very important. For example, you are just given a speed time graph and you're looking for distance travel, and how can you find distance from speed time graph? You can find distance from distance time graph, but what speed time graph? The answer is for the region you are asked to find distance, all you have to do is select that region on the graph and find area under the graph. For example, let's do a simple curve. Let's start with this. If we have this kind of curve, this is speed in meter per second, and this is time in second. Let's say this speed is 20 meter per second, and this happens in 10 seconds. Now, this is question. Question is, use graph on the left to find number one, acceleration at 7th second. Number two, distance traveled in 10 seconds. Now, the first question is a little bit, I can say that it is a kind of trick question. Now, 7th second, an average student will start looking for example, if this is 0 and he's very intelligent and he will go over here and try to find out where the 7th second is, and then go to the graph and kind of lost somewhere. Actually, it is a trick question.
Teacher, I
Look at the
know.
line. Yes.
Since it's a constant, so we just
Yes.
find per second and then multiply by 7, I think.
No. What we do is we find the acceleration of the 10 seconds. Instead of coming to smaller value, we go for the bigger one because there will be less chance of making an error. Again,
Okay.
with one, it will still be like very small, and still you have to guess the value. So what you could do was find the acceleration for the whole thing, because it is a straight line. It doesn't matter whether you find acceleration for the first second or second second or third or fourth or fifth or sixth or seventh or eighth, because acceleration is constant all along. So if you find the total acceleration or acceleration at any point, the answer should be same. So in this case, acceleration will be the gradient of the graph, which is rise over run. So what is the value of rise for the whole thing?
20.
And what is the value of run?
10.
So if 0 cancels with 0, you get 2. So what will be the value of acceleration?
2 meters per second squared.
Again, that is wrong, because remember, whenever you get a whole number, single whole
2.0.
number answer, you have to make it two significant figures. So 2.0 meter
Okay.
per second square. Now, distance traveled in 10 seconds. What feature of a speed time graph is distance? Answer is area. This area is this. Now look at the shape of the area. When we say area under the graph, what does that phrase mean? The red line you're looking at is the graph, and x-axis, which is the time axis over there, is the horizontal axis over here. All the area trapped in between these two lines is called the area under the graph. So area under the graph, this phrase means area underneath the graph till you get to the x-axis or the time axis. Now, what kind of shape is this? If you just look at the shaded region, you will find
Uh,
out find it
Triangle.
like a triangle. And what
Yes.
is the area of a triangle? What is the
Uh,
area of a triangle?
half base times height.
So in this case, I will not say it is area. I will say distance traveled equals to half time base times height. So it will be 100 meters. Okay. So should I give you another question?
Sure, sir. I
Let's
don't
see.
mind.
This is the question. This is velocity axis. This is x-axis. Actually, the time axis. And this is the graph. This is speed in meter per second. 5, 10, 15, 20, 25, 30. And this is 0. This is time axis. This is 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 12. Time in seconds. Calculate. Number 1, acceleration in first 6 seconds. Number 2, distance moved in 12 seconds by the object. Let's see if you can solve the question. If you need help, you can ask. So the dotted lines are there to tell you the turning points.
Sir, is that first 6 or 5 seconds?
Mm, 6 seconds.
Okay. Sir, do I I just need to draw a line up, like a straight line, right? Or should I do it the way we did in the last question?
No, actually, it is slightly different than that because still you have to find acceleration for the whole thing instead of just finding it for 6 seconds. Actually, that is the same kind of trick because it is a straight line. You can find acceleration for the whole 12 seconds, but you have to be careful for the rise.
What do you mean, sir?
Listen, normally, what do you think? What will be the rise in this case if you may complete a triangle?
It would be 20.
Yes, then you have already taken care of. Most of the people think that it is 30.
Oh, okay. Because it
So
starts at 10, that's why.
yeah,
It's
that is the case because when you make a triangle on the top, the triangle has a rise of 20, not 30, and the run will be 12. So acceleration will be 20 divided by 12.
okay. But then like, oh, okay, okay. So that's
And for distance, you will not only find the area of the triangle
you
because
also have to find the
when
rectangle.
yes, because we have to find area under the graph, and that means from the graph, which is the red line, to the time axis, the whole thing, not just the triangle, but the rectangle underneath as well. You can use the area of the formula of area of a trapezium, and if you don't know that, you can just simply find area of the triangle and then area of rectangle and add them. Let me know what your answers are, and then we can go forward and solve another question.
Sir, for the first,
Your voice got interrupted. Can you repeat?
so I got 1.6 meters per second squared.
You made an incorrect rounding off over there, so it
1.7.
will be. Oh, see, like you cannot be casual about that. Just try to make it
Okay.
your natural thing that whenever you're ignoring a part of something, you have to consider it like, is it significant to the previous value or to the next value? Like 1.64 is good to be 1.6, but 1.65 something cannot be 1.6. It has to be 1.7 because it becomes closer to 1.7.
Okay.
Good. So
And for the second one, I got 240 meters.
distance travel will be 1 over 2 into 12 into 20 plus 12 into 10. Then 120 plus 120. Is that so? Are you getting 240?
Yes, sir, that's what I said.
Oh, good, good. You got it right. So This is the kind of questions you can see in exam, and examiner can ask you to replicate any of these questions as well. I hope you draw these graphs and recorded the description. Okay, we discussed that in the last class. Do you remember that?
Yes.
Good. So we are good to go for past papers, and we will start with MCQs over here. Okay, now.
So I just wanted to ask him, by what time are we like approximately gonna end the syllabus?
My like prediction is that we can end it in the
Okay.
March that is coming, and because we are not just only studying, we are doing the past papers along. If we just study, we can end it in like February, but we are not just studying. We're doing past papers with it, so that increases the time, but it is good because there is no other way to actually know if you have done the topic or not. The only way is you solve past papers and then you end it. And I'm sending this PDF to you because it is topical MCQs. And at the end of every topic, we can do some questions and see if we understand the topic or not.
Okay, so I send them to you by next class.
No, no, no. You cannot solve them all over here.
Yeah,
It
like
will
I'll.
come to you. We are right now discussing those questions class right now.
Oh, okay.
Look at this screen. Can you see the screen?
Yes.
Okay. Can you tell me the answer for the first question? Read the question carefully.
The diagram showed a speed time graph for a body moving with constant acceleration. What is represented by the shaded area under the graph? Distance.
Oh, you got it right. So your answer is B.
Yes.
Okay. Another question.
A tunnel has a length of 50 kilometers. A car takes 20 minutes to travel between the two ends of the tunnel. What is the average speed of the car? 150 kilometers per hour. C.
You are genius. Like how did you manage? Like did it? Did you convert 20 minutes into hours?
So I first divided it. So that was per minute. So then I just multiplied by
Mhm.
60 after that.
Oh, that is a very dangerous way of doing it. But yes, you're right. Otherwise, what you could do is you could just divide 20 with 60 and get 1 over 3 as time, and then 50 divided by 1 over 3 will make 150, and you should have get the same answer. But yes, your method is good if you actually know what you're doing, because you got 20 divided 50 divided by 20, that will give you 2.5, and that is not kilometer per hour, it is actually kilometer per minutes. So if something is traveled 2.5 kilometer in 1 minute, it will travel 2.5 into 60, 150 kilometers in 1 hour. So this is what you use, but that is a very dangerous way. If
Okay, so I'll use the way you said.
okay. No, I'm not discouraging you, but if you actually knew what you're doing, then it is okay.
Okay.
Let's see if you can do the next question.
Sir, I got
Mhm.
6 meters.
And how did you do that?
I just did 3 times 2.
Because we are actually finding area under the graph because it is a speed time graph. For distance we find area, and look at the shaded region underneath the graph. It is a rectangle with length 3, width 2. So length into width 2, 3 into 2. So, and if you use the formula distance equals to speed multiplied by time, and that can only work with constant speed, which it is, and you can get same answer as well. Hmm, we haven't done a resistance yet. Let's do this one. Question number 6.
A car accelerates from traffic lights. The graph shows how the car's speed changes with time. How far does the car travel before it reaches a steady speed? 100 meters.
How did you do it?
I just did the formula for a triangle, half base times height.
Good. You actually calculated the area under the graph. Good. Question number 7.
A man stands by a railway track. A train
Mhm.
traveling at 40 meters per second takes 2 seconds to pass the man. What is the length of the train?
So man is standing still. The train is running at a speed of 40 meters per second, and it takes him a complete 2 seconds to completely pass the man.
So I think it's a D, 80 meters.
Yes, because in this case, the length of the train will be the distance that the train travels in 2 seconds. That will be 80 meters. Good. D. So there's the same kind of question. There's no point of doing it. You can just do it later. Let's see if you can do question number 9.
Uh, the graph shows the progress of an athlete in a 100-meter race. What time was taken? What time was taken to travel 10 meters from the start?
I hope you can clearly see the screen.
Yes. So can you show me the MCQs? I think it was a.
There's no other information. That's it. The question starts with this. The graph shows the progress of an athlete.
Yeah, I was just counting the boxes to see where's the 10 meters.
Okay, so you need the zoom in part like this.
Yeah, thank you. I got 2.8 seconds. So B.
Good. Okay. A circuit of motor racing track is 3 kilometers in length. In a race, a car goes 25 times around the circuit in 30 minutes. What is the average speed of the car?
So I got 150 kilometers per hour.
So when you convert 30 minutes to hours, it is 30 divided by 60, 0.5. And the total distance travel will be 3 kilometers for one circuit and 25 times around the circuit. That means 75 kilometers in 0.5 hours. 75 divided by 0.5 is 150 kilometers per hour. And even if we do it your way, 75 divided by 30 is 2.5 and 2.5 multiplied by 60 is 150 kilometers per hour. Okay. Let's see if you can do question number 12 and 13.
13, sir?
12 and 13, both.
Okay. The speed time graph shown is for a bus traveling between stops. Where in the graph is the acceleration of the bus the greatest? B.
Not C.
Why would it be C, sir?
No, I am not saying it is C. I'm saying why it is not C.
I just used that method you taught us about the angles, where you draw a fake x-axis.
Actually, it is not about the value of speed. If somebody would have asked that where the object is traveling with the traveling fastest, it would be C. But where its velocity is increasing at the highest rate, it will be B, because that is the region where it has maximum slope, maximum gradient, maximum angle with x-axis. Very well done. Good. What about question number 13?
A car travels 100 kilometers. The highest speed of the car is 90 kilometers per hour, and the slowest speed is 30 kilometers per hour. The journey takes 2 hours. What is the average speed for the journey? I don't know how to take this one.
Can you just simply ignore that 90 and 30?
Then I would say it's 50 kilometers per hour.
And that is the answer. Actually, that is to mislead you. You need to know average speed is total distance divided by total time, not the maximum divided plus minimum divided by 2. What happens is student starts to think if it is 90 maximum, 30 minimum, if I do 90 plus 30 divided by 2, I should get 60 kilometer per hour. That is the average speed, but that is to trick you.
Oh, okay, sir.
Okay. So answer is
B.
B. Good, good. You have done many questions like this. I think you can easily do that. Let's do this. Let's see this. Question number 15.
Two distance time graphs and two speed time graphs are shown. Which graph represents an object that is at rest? D.
D.
What, sir?
Did you say D?
No, B, B.
Bravo or Delta?
Bravo.
Bravo.
Yes,
Bravo then. Yes. Good.
thank you.
Oh, okay. This is a good question. Read the question and solve it and tell me the answer.
Okay. B.
Again,
Yes, B.
and you're right. I said that acceleration time graphs, they very seldom appear, but they do. Here's an example.
A stone falls freely from the top of a cliff into the sea. Air resistance may be ignored. Which graph shows the acceleration of the stone varies with time as it falls? I think C.
No, it is not the distance time graph. That would be very good answer for a distance time graph, because distance is increasing at an increasing rate. Distance fallen by the object because the speed will be increasing. So C is a good answer if it would be a distance time graph, but he's asking for the right acceleration time graph.
I don't know, sir.
A would be an answer if it would be a velocity time graph. And when object falls, it falls with a constant acceleration of 10 meter per second square. So answer has to be D.
Sir, so okay,
Mhm.
so you don't need to know what's an acceleration time graph, right? Because it falls
Yes.
at a constant. Okay.
Mhm. Okay. Question number 21.
Which speed time graph applies to an object at rest? D.
B.
D. Delta.
Good. Okay. This is the question where you have to apply your mind a little bit.
D.
Nope.
I don't know, sir.
Now, which set of data shows that the car is increasing in speed during the 2 seconds? Look, this is very much like the example I gave you with the three cars. Do you remember that car number 1, 2, 3?
Yes, I do.
So listen, here we go. This car starts from zero, and in 1 second, how much distance does it travel?
100 meters.
And the second, how much distance it has traveled from 1 to 2?
100 meters.
So it is traveling with a constant speed, huh?
Yes.
Okay, look at this one. How much distance did this car travel in the first second?
Okay, yeah, this is the answer. It traveled 80 in the first second.
And in the next second?
110.
And what about this one?
This one is 90 in the first, and then 110 in the second. I mean,
Hmm?
90 in the second. Sorry. So 90,
So
90.
this is again traveling. This is again traveling with.
Constant.
What about this one?
This one is a decreasing because it's 100 and then 80.
So you have to slow down when this kind of complicated question comes in. Read it again, slow down the RPM of your head, try to understand the question. It is very simple when somebody explains it to you. I did not tell you the answer. I just showed you how the question is designed. Well, and in the exam, you have to do it yourself. I have shared this PDF with you, and this is a very long PDF. I think it has 250 plus pages. What you have to do is you have to go to the topic of kinematics and try these MCQs yourself, and let me know
Uh,
if you find a question that is tough and you could not make sense out of it. So we will repeat that in the
okay, how
class.
many would you
Okay.
like me to do?
Like there are like 30 questions and we have already done 20. So complete the topic, the kinematics topic.
Okay.
Okay. This is, I think, the third topic in the PDF. And you don't like need to write the question. You just write the question number and its answer.
Okay. And sir,
Okay.
for tomorrow's class, can you record it or can we, because I won't be able to attend tomorrow. Or if it's just me, then
Uh,
can we do it
okay.
another day?
We can shift it to another day.
Okay.
Okay, I
Because
will record it if somebody else comes into the class because everybody's waiting for the recording, and I cannot teach if there's no person. Like it is good to talk to somebody like right now I'm doing, but
yeah.
I cannot keep talking to a machine. That that is
Yeah, no
very
problem.
weird. So if somebody else comes, I will record the class and you can have the recording. And if nobody appears, we can do this class on some other day. Huh?
Okay, sir. Thank you.
Okay. Welcome. Take care. Allah Hafiz.
Allah